We would like to determine whether the complex series summation k equals 0 to infinity of I to the k over k factorial converges or not. So we're going to use the fact that if a series converges absolutely, then it converges. So in the complex case, that means that if the sum of the modulus of ck converges, where k goes from, say, 0 to infinity, then the summation of ck without the modulus symbol, k equals 0 to infinity, also converges. So this is called absolute convergence. It looks just like the real case of absolute convergence, the difference being that the absolute value bars, when we're dealing with complex numbers, means modulus instead of absolute value. It agrees with the absolute value in the case that the complex number is purely real. If the ck is a real number, then the modulus is the same as the absolute value. Okay, so here, our ck here is I to the k over k factorial, and I to the k is equal to either plus or minus 1 or plus or minus I, depending on what k is. But in any case, the modulus of I to the k is 1. And therefore, the modulus of ck is the modulus of I to the k over k factorial, which is the modulus of I to the k over the modulus of k factorial. And that's 1 over k factorial. K factorial is a positive real number. Its modulus is the same as its absolute value, which is itself. So now we consider the series summation of 1 over k factorial. K goes from 0 to infinity, and this is 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial, etc. And we have to recall here that 0 factorial is 1. And this series is known to converge to the number e. So this series does converge. Its sum is well known. We can show that it converges using the ratio test. But okay, so since this series converges, this series also converges. It converges absolutely.